Can you see me and can you hear me properly? So,
Yes, sir, we can hear you.
okay, thank you. So, so this is our example one. Okay. So we have a signal xn is equal to alpha n un. Okay. So this is our signal. Okay. So we are okay. Thank you. So we need to find the is a transform of xn. Okay. And ROC. So this is our question. Okay. So we will do this. So still we are at the beginning. Okay. Still we are at the beginning. Okay. We have to go further. Okay. So after doing this example, we will move forward. We will move further. Okay. So okay. So okay. So you know that this un, that is a unit step function. Okay. So you already know that un is a Cauchy signal. Okay. So what is un? It is a Cauchy signal. CAUSAL, no? Cauchy signal. Okay. That means it has only plus-sided value. Plus-sided value. Values only, but plus-sided samples only. That is meant by Cauchy. Okay. If we have minus-sided only, okay, like this, okay, only this minus ID, okay. So that is an anti-Cauchy signal. Anti-Cauchy signal. Okay. Okay. So you know that un is somewhat like this. So we have first sample here at 0. Okay. So this is plus 2, third, so on up to infinity. Okay. So this is un. Okay. So so here you have in un you have given a restriction. No, you have given a restriction that n from 0 to plus infinity. Okay. So here you are, so if you are given un, okay, if you are given unit step function, okay, so we know that unit step function is defined between 0 and plus infinity. That is how unit step function is defined. Okay. So if you are given this un, okay, that means you are given a restriction that the n should be 0 to plus infinity. No minus sides values are there. Okay. Actually, that is the use of this un. Okay. This un has no any impact of this signal. Okay. Actually, this signal is xn. Okay. But this un only gives, okay, only gives you the gives a sign. Okay. It is a sign about the n range. Okay. It is sign about the n range. It is an indicator. It is just an indicator about this n range. Okay. So if you get the alpha n signal, okay, alpha n signal, if you get the alpha n signal, okay, so this is n, okay, and this is alpha n. So this alpha is a real value, okay, this alpha is a real value. Let's say it is a real value. Okay, I will explain why I tell it as real value. Okay. Okay. Can you imagine what if this alpha is a imaginary value? What is the impact? Can you imagine? Can you imagine? Can anyone image? Okay, I'll tell you. Okay, actually these are not related with the Z transform. Okay, but these are related with signal and system concept. Okay, but I think you should have this knowledge. Okay, so don't think this as a waste of time. Okay, so I think if you have this kind of knowledge, it is better. Okay, actually finally uh, you will remain this kind of knowledge. Okay, after the exam you will forget all the mathematicals and definition and other things. Okay, but what you remain is the idea you have get, and that idea is important, and it is uh, it is a help for your future engineering life. Okay, so we can't remember all the things we are learning, no? Okay, but when you are learning something, you should get the idea. Okay, uh, uh, comprehensive idea about uh, the stuff you learn. Okay, okay, so let's say so this alpha is so this is xn anyway. Okay, so alpha n, so this alpha is a real number, real value. Okay, so here are we given any restriction about the n range? No. Okay, so this n can be minus infinity to plus infinity. Okay, so we are not given any restriction about this n. Okay, so that n can be minus infinity to plus infinity, but here we are given a restriction because un is defined only within 0 and infinity. Okay, okay, so 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 the shape of this function is mainly depend on the value of this lambda, value of this alpha. Okay, I think you can understand this. Okay, for example, let's say that alpha is greater than 1. Okay, alpha is greater than 1. Okay, that means alpha can be 2, 3, 4, 5, 6 like number. Okay, or it can be a decimal number 5.5 or anything. Okay, but it is a plus number greater than 1. Okay, so what happened? Okay, so you can see that the alpha so this n can be 0, 1, 2, 3 up to plus infinity. Okay, and also minus 1, minus 2, minus 3 up to minus infinity. Okay, so if this the n is 0, alpha 0, that is alpha, whether alpha is any value, alpha 0. Okay, any value the power 0, any value to the power 0 is equal to 1. No, so this will be 1. Okay, so our first sample, 0th sample will be 1. Okay, okay, let's say alpha is equal to, okay, alpha is equal to greater than 1, that is 2. Then this point, okay, this point it is, so here the first point is 2 0, that is 1. Okay, if it is 2 1, that is 2, so that means it is greater than this value. Okay, so it will be like this. Okay, and if you have the alpha is square, so this is n is 2, no, so it is alpha 2, that means alpha is square. So if alpha is 2, you will have 4 here. Okay, so you have a great value here, and if it is 3, you have 8 here. Okay, so you can see that it is exponentially increasing like this. No, okay, like this, it is increasing. Okay, so if you consider the minus 1 sample, that means 2 minus 1, that means 1 by 2, so you will have 0.5. So it means that it is less than 1. Okay, so if you have minus 2, that means it is 2 minus 2, that means 1 by 4, that is 0.25. Okay, so you will have a value less than this one. So like this, here it is decreasing up to infinity. Okay, so your variation will look like this. Okay, so that is alpha is equal to alpha is greater than 1. Okay, what happen if alpha is what is that called, rational number, or bhaga sankhya? I can't remember the word. Okay, let's say that alpha is between 0 and 1. Alpha is between 0 and 1. So that is a only a decimal point value. No, there is no the complete value, only decimal. Okay, half number. It is a half number. I don't know the exact name. Okay, so if you can remember, you can remind us. Okay, so it will be just like this: 0.5, 0.2, 0.3. Okay, like this, any half value. Okay, so what happens? Okay, so you can see that the 0th value is 1, no issue. Okay, and first value is, if it is 0.5, first value will be 0.5. So it is less than this one. Okay, and it is less than this one. Next sample is less than this one. Next sample value is less than this one. Okay, and if you get a minus 1, that means 1 by 0 point. Okay, so that means you will get 2. No, so it is greater than this one. Okay, so if the alpha is between 1 and 0, okay, you will get this kind of signal. Okay, this kind of signal. Okay, so this we get. Okay, this we get if the alpha is greater than 1. Okay, and this we get if alpha is between 0 and 1. Okay, and what happen if alpha is a minus value? That means alpha is less than 1. Okay, less than 1. You will get sample plus and minus sample, both plus and minus sample. So your first sample will be plus, your second sample will be minus, your third sample again will be a plus value, third sample will be again minus value, so on. Okay, so you will get this kind of pattern. Okay, so what I want to tell you is that this pattern, the variation, okay, pattern of the signal is mainly depend on alpha. Okay, so what happen if this alpha is a imaginary value? Okay, what if this alpha is an imaginary value? Okay, so if we going to plot the imaginary value, you can see that to plot the imaginary value, we need to have 2 dimension, no? Like this. Okay, so this will be your real axis, this will be your imaginary axis. Okay, and the n is another dimension. This is n. Okay, so you can see that if alpha is real, it is a 2-dimensional signal. Okay, if alpha is real, it is 2-dimensional signal. 2-dimensional. Okay, but if the alpha is imaginary, it is not a 2-dimensional signal, it will be a 3-dimensional signal. 3-dimensional signal. Okay, but in our course we are not talking about 3-dimensional signals. Okay, but if you get the picture or something, if you get the picture, okay, if you get the picture, and if you convert this picture into a signal, so that that signal will be I think I can remember, I think this is 1-dimensional and this is 2-dimensional. No? Okay, so this is 1-dimensional. Okay, and this is 2-dimensional. Okay, so your picture will be 2-dimensional. Okay, so if this alpha is infinite imaginary value, it will be a 2-dimensional signal. Okay, so those signals still we are not dealing with the 2-dimensional signals. Okay, so you can notice that when we are given this kind of signal, always we have told that this alpha is a real value. Okay, okay. So for our example, this knowledge is not much important. Okay, this knowledge is not important because we are already given that uh, alpha is a real value. That information is enough for us. Okay, for somehow, if it is a imaginary value, we can't do this process. Okay, so we have to think about another procedure, another approach. Okay, so if we are given this alpha is a real value, no issue. Okay, if this pattern is anything, it is okay for us. Okay, so 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 here, mm, so here, so what happened? So here you can see that these two signals are multiplied together, no? Alpha n and un multiplied together. So what happened if I multiply by this un by alpha n? Okay, the resultant signal. What is the resultant signal I get? What is the resultant signal I get? Okay, what is the resultant signal I get? Okay, you can see that here for un there is no sample, all are zero. Here all are zero. Okay, so if I multiply this zero value from this value in so this is our this is our resultant signal alpha in un. Okay, sorry. So this is alpha in un. Alpha to the power n. Okay, alpha to the power n un. Okay, so our resultant signal, this is no value, all are zero, and our signal will start from here. Okay, and we have this value 1. Okay, and if let's say that, let's imagine that alpha is greater than 1, so we will have this kind of samples. Okay, because here it is 1 and all samples are multiplied by 1, so we will get the same value, alpha n value. Okay, so here actually by by multiplying the un, okay, multiplying the unit step function, only the n value is restricted, no? Okay, okay, you get it. Okay, so alpha n un. Okay, so this is our xn actually. Also, we can write this in this way. Alpha n, okay, xn equal alpha n if n is greater than 0, and plus infinity. Okay, and 0 if n is less than 0. Okay, so this is equal, greater than or equal to 0 or plus infinity. Within 0 and plus infinity, the value is alpha n. Okay, so if it is 0, if the n is less than 0. Okay, actually to write this we need two line. Okay, we need two line. Okay, we need two line and one bracket. Okay, so here you have avoid that bracket and two line, so you have write this same signal with in a one line using this un. Okay, that is the only advantage. Okay, so don't confuse with this kind of things. Okay, any problem? So if you have any problem, you can stop me and ask me. Okay, anytime. Okay, okay, so quickly I think now you can perform the Z transformation. Okay, I think if this signal is finalized, you can perform Z transformation. Okay, before that, I also emphasize you one thing. Okay, I also emphasize you one thing. Okay, okay. So are there any guarantee that these samples and the un samples and alpha n samples are same or not? Okay, because this n is 0, 1, 2, 3. Okay, and this n also 0, 1, 2, 3. But can we say that this 0, 1, 2, 3 value and this 0, 1, 2, 3 value are same or not? Can we tell? Can you understand my question? Okay. So here n is 0, 1, 2, 3. And here n is 0, 1, 2, 3. Okay. So if it is a time, there is no issue actually, because time is measured in a second or millisecond or some second. Okay. So for this signal, okay, I will write it and explain. Okay. Okay. So, so I will get around 5 minutes to explain this. Okay. So if you say that you have this kind of signal, this kind of sinusoidal signal, and another you have another signal, it may be a high frequency signal like this. Okay. So if this time is measured by millisecond, and if this time is second measured by millisecond, so if you get the time second here 1, and if you get the time second here 1, so this is also referred to 1 millisecond, and this is also referred to 1 millisecond. So this point and these points are and identical. Okay. So if you multiply these two value at this time instant, so this value and this value will be multiplied. Okay. For example, if this value is a1 and if this value is a2, okay, so if you multiply the first signal at this time point t1, let's say this is t1 and this is t2. Okay. And sorry, t1, so this is also t1, no, because in one time sample, so this is x1, if this is x2 t1. Okay. So you will get a1 multiplied by a2. Okay. So no issue. Okay. But let us have a two discrete signal. Okay. Let us have a two discrete signal. Okay. So what is a discrete signal, and how we can generate a discrete signal? So by sampling, no. Okay, we can generate a discrete signal by sampling a continuous signal. So if we have send, so say that we have a sine signal, sine theta signal. Okay. So if we have sent it through a sampler, okay, that means it is a switch. Okay. Okay, switch. Okay. So we will get a some kind of discrete signal like this. Okay. Some kind of discrete signal like this. Okay. Okay. So let's say that we on and off this we off this sampler after 1 millisecond, after 1 millisecond. Okay. So that means I think you have done the sampling. Okay. So this concept you should understand. Okay. If you have any problem, you can ask me. Okay. Okay. So if you these are very so this kind of problem we will face in practice actually. Okay. If we are adding or multiplying two signals, okay, in practice, if maybe for your final project, okay, if you want to add two signal, okay, add two discrete signal, you have to care about this. Okay. If you want to multiply two discrete signal, this kind of things you should be careful. Okay. Otherwise your result will not be the expected one. Okay. So let's say that this sample, so this switch is on off after 1 millisecond. Okay. So here we will get the first sample. Okay. Then after 1 millisecond, okay, after 1 millisecond I will get another sample. After another 1 millisecond I will get another sample. After another 1 millisecond I will get another sample. So on, I will get some sample. Okay. So these are sample value. Okay. So I can say that this is 0, this is first sample. Okay. This is second, third, fourth, fifth. So okay, is n. Okay. This is n. The sample number 0, 1, 2, 3. Okay. And if I sample the same signal, with two milliseconds, okay, with 2 milliseconds. Actually, this is the sample period. This is the sample period. Okay, so 1 by sample period is the sample frequency. Okay, so here I sample the frequency, sample this signal with the one frequency, and I sample the the same signal with another sample frequency that is twice actually. Okay, so here not twice, half. Okay, so this is 2 milliseconds. Okay, so I will get first sample here 0. This is my first sample. Then after 2 milliseconds I will get another sample. After 2 milliseconds I will get another sample. After 2 milliseconds I will get another sample. So if I denote this using n, here also I have 0, 1, 2, 3. Okay, so if you want to multiply this first sample, the first sample and this first sample, okay, 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 okay. So here this is the first sample. Okay, so this is 0 sample. This is the first sample. Okay, so if you add this sample to this sample, okay, what happen if you want to add or multiply? Okay, here you can see that this sample is not upon this sample, no. Okay, so here it is 1 millisecond and this sample is related here in the 1 millisecond. Okay, so if you multiply this time sample times value and this time value, okay, what happen? You will get 0. Okay, so you will not get the expected value. Okay, okay, did you get that? Okay, so you can see that if we have if we have so this n, so another important parameter is this n is always related with the sampling time. Actually n is equal to the time is equal to n t naught, sampling time. Okay, so this is the relation in your sampling. I think you have learned this. Okay, when you are doing the sampling, you have learned this. T is equal to NT naught. So this is the sampling time. Okay. Okay. So you can see that if we are going to do it in time domain, okay, because when you are adding, you can see a time value. You will see a time value, not a sample value. So if you multiply these together, okay, so this sample is not exactly on this sample, first sample, no. So here the first sample is 1 millisecond. Here first sample is 2 millisecond. So if you add this, okay, if you add this, you will not get the same result. Okay, what you have to do this, you have to have a delay. Okay, you have to have a delay around 1 millisecond delay and you have to multiply. Okay, okay, otherwise you will not get the corresponding value. Okay, but if this sampling rate and this sampling rate is equal, so this will also have the sample within 1 millisecond. Okay, this will also have the 1 millisecond. So if this first sample is aligned the other first sample also, then you can multiply it without the problem. Okay, so what I want to tell you is that, okay, so if this sample n, okay, if this n has another frequency, sampling frequency, and if this has another frequency, sampling frequency, so you can't simply multiply this. Okay, you have to give a delay and multiply it. Okay, but when we are given this kind of function, okay, we can always assume them, okay, these samples and these samples are superposition is each other. Okay, superimposed is each other, so that can we can assume that. Okay, okay, so I think you get the idea. Okay, so we will try to find the Z transform. Okay, okay, so so if I get the XZ transform, okay, so you know that n from minus infinity to plus infinity, xn z minus n. So this is the z transformation. So in our case, n is from 0 to plus infinity, okay, because only 0, the one-sided sample is there, the plus-sided sample is there, that means it is a partial signal, okay. So it is n from 0 to plus infinity, okay. So if you get xn, that is alpha n, okay, alpha n, okay, z minus n, okay. So this is what we have. So what you have to do is you can get the sum by substituting the value for n, okay. So if n is 0, we have alpha 0 z minus 0, plus if you have n, you have alpha n z minus n, sorry, alpha 1 z minus 1. If alpha is 2, if n is 2, alpha 2 z minus 2. If n is 3, alpha 3 z minus 3, so on up to infinity, okay. So you can see that this is 0, okay. So this is 1, okay, this is 1, alpha 0 z 0 1, okay. So you have here alpha divided by z, plus here alpha square divided by z square, okay. So that means alpha divided by z square, plus here alpha to the power 3 z to the power 3, okay. So this is minus 3, so that is what I get it down, okay. This is why, that is why I get it down, okay. So this is alpha 3 z3, so alpha z3, so you can write this as alpha pi z3, okay. In same way you can find alpha by z4 4, so on up to infinity, okay. So what is this? This is a power series, okay. So this is a power series and also geometric series, okay. So Taylor, that is a Taylor, okay. This is the guy, we can, this is the guy come to our mind, no, when we see this kind of series, okay. So so this is just a power series. It is just like 1 x plus x square, this kind of power series, okay. 1 plus x square plus x to the power 3 up to infinity, this kind of series. So we know that this kind of series, we have 1 divided by 1 minus x, okay. And we have a restriction for this x, okay. X should be less than 1, okay. So this is the series, okay. So this is the series. I think last time also we have used this, okay. So no need to keep remember these things, okay. If you need this when you are doing a problem in exam, you will be given the expansion, okay. So so we have, okay, so we know that. So in this way we can write this, okay. So xz will be, okay, so xz will be 1 by 1 minus x. X means here alpha by z, no, alpha by z, okay. So this is our xz, we have found that. Then what is the ROC? To find the ROC, we have to consider this restriction, okay. So this x should be less than 1. So what is the x here? Alpha by z, no. So this x, the square of the magnitude of this x is should be less than 1, okay. Magnitude, this should be the magnitude, because this can be a complex value also, okay. So this will be the magnitude, okay. So x magnitude should be less than 1. What is the x here? Alpha by z. So we have alpha by z magnitude less than 1, okay. Alpha by z magnitude less than 1, okay. And we have, okay, what we have here. So we can have a cross product, then we can say that magnitude of alpha should be greater than magnitude of Z. Okay, so what is the ROC for this? Okay, so ROC is Z greater than alpha, magnitude alpha. So what is this? If we draw a circle in the Z plane, okay, so this is real Z and this is imaginary Z. If we draw a circle with alpha value, okay, so this Z should be greater than alpha. So that means this area, no? Okay, the area beyond this circle is the ROC for this signal, for this axis. Okay, okay. Now please try to find this one by yourself. Okay, please try to find this one by yourself quickly. If we have given xn, okay, let's say that x2n is equal to alpha minus n u. So please try to find the Z transform. Try to find the Z transform and try to find the ROC. Find the ROC. You can use the result. This result. Okay. If you use this result, it is okay. Okay. And try to find this and tell me the ROC within 5 minutes. Okay. So what is the ROC for this?